Hello friends, hope you all doing good. So today I'll be talking about little bit on the cache, that to Hazelcast caching with the Springboot and how to deploy the Springboot application along with the Hazelcast into ECS. Okay, so before we start, I would like to talk a little bit of caching, where using the caching we can increase the performance and latency will be less. The response time will be high for that one. And I'll be not talking much about caching on the different strategies, but we'll be using the normal caching mechanism where if you have a static data and you are getting request for that particular data every time, so you need not to go to the database every time and get the values. And Here, since we are talking about Hazel cache, it is a in-memory cache. So when we talk about in-memory, so it will be usually attached to the application along with the application in the same container, or it will share the same RAM and all. We are not going to have a separate cacheable mechanism or cache as a service mechanism. So there are different ways we can achieve this one, like per instance, like we can keep cache embedded inside the instance, and each instance can have its own cache. Like if you use Spring Cache, which uses concurrent hash map, so internally what happens is like whenever an instance is created, that the request which is coming to that particular instance, it will be cached, and second time when the same request comes, it will get it from the cacheable memory. So but what happens is when we scale the application for the performance, so that time we need here it will be increasing the number of cache along with the instance. So this actually kills up first of all the memory size, and second thing is like the same data, if multiple instances will be hitting, and the data is same data will be cached, and it is a redundancy, I can say. To avoid that better, we need to go for a distributable cache, which is like we'll have a specific cache, and we can increase definitely can increase the nodes of the cache to have the high performance. But internally what it does is like it shares the data among itself. So here we can see like if multiple instance, 3 instances are there, if one instance is calling the node 1, and in node 2 also you'll get the same data back because it is already clustered over there. And since instance 3 is catch up with the node 2, and it is this cacheable is distributed and it is clustered, here the data shares among the nodes. So the I can say like availability and fault tolerance would be more achieved over here. So when it comes to the cap theory and all, if you see, the main thing they notice is availability, consistency, and the fault tolerance. So here we can achieve the availability and the fault tolerance more in this manner. And for this, there are many other distributable caches, but today I will be going to discuss about the Hazel cache. So just brief description, like in a Hazel cache is a in-memory data grid for clustering and high scalable data distribution. So it does the same thing what I was talking about this diagram. So it will have its own cluster, and it will be bound to all the instances we are we are attaching to that one. So um, so mainly we have to import dependency like Hazelcast with Hazelcast all in POM. You can go for Gradle, some other kind of scripts. I think you can easily get it in the Google. So in my example, I used POM, Maven dependencies. And in the Java code, we can see here, we have to use the enable cache, we have to use this annotation along with the Spring Boot application. And cacheable name we have to specify one name for particular caching. And we can provide later on the keys also. Yes, like if we have multiple parameters, we can specify which parameter we want to cache it. That way also we can use it, but currently I'm using default by name. So this is the default structure or the implementation of class level. If you use Spring Cache also, same thing we can use it. So the main key point is we have to add a Hazelcast YAML file. So we have to provide it should be multicast enabled true if you want to set up in the local and test it before you want to deploy it. But when you are deploying into the EC2 instance and all, we need to have this particular configuration where we have to say for AWS, and we have to disable the multicasting here. And for AWS, we have to say true, and we have to have a say interface true. So here what happens is like since we are connecting to the VPC, and the distributable nodes will be identified by themselves using this interface. I can say IP address with the discovery server in the AWS. So we have to specify correctly, like if you have created your own VPC, and what is this CIDR number. So we have to specify the same, like minus 10.0 and star is the, because that IP changes for multiple subnets. So that's why we initial two values we can provide here. And after that, we have to actually create a role for a specific Hazelcast, because Hazelcast looks for the particular role, and for identifying the cluster for discovery. So for that, we need to provide a policy first. Create a policy for ECS, which is for describe task and list task, and it is applicable for all the resources. And for EC2 also, we need to provide for describe network interfaces. This is mainly meant for identifying the discovery server. For discovery server, it is mainly used. For once you create this policy, we have to attach to a IAM role. And when you are creating a EC2 cluster, we have to specify the newly created role, whatever it has a policy in this one, it will be applicable for that one. So that is the main steps, and I'll be demonstrating all those things in the demo, and I'll be sharing my GitHub repository and Docker Hub repository for the images. I think that's it. I think we can start demo. Okay, let's move on to the demo. Okay, to create IAM role, so we'll do first create policy. Let's try to create policy, choose the service. So first we need to provide the ECS service. Just a minute. Okay, it will be Elastic service. In this, we have to provide here we have to grant the permission for The first one is describe task, and another one is list the task. These two permission is required for ECS. And next is we have to provide, we need to get resource for all resources it will be applicable for. And next is okay, I will not go for request condition. Okay, we'll add additional permission, which is for ECS, sorry, EC2. So we have to search for EC2. Okay, in the EC2 we have to grant permission for it is also for describe network describe network or let me try network interface. Yep, describe network interface. This is for the service discovery. Whenever we have the Hazelcast cluster, it should automatically detect from themselves. For that we have to add these things. Review the policies, and we'll give a name like my Hazelcast policy. Okay, you can give the description like this is for Hazelcast cache. Okay, and we'll create a policy. Now we'll go for role. I'll go for role. I'll do a create role, and here AWS service for EC2 instance, and here's for, I guess we can go for ECS also. Is there? No, I'll not go for EC2, I'll go for ECS. Yeah, Elastic Container Service. Then I'll choose Elastic Container Service task. Then add permission. Okay. Here we will search for the newly created policy word. My Hazelcast policy. Yes, this one. So tag it, say name Hazelcast review, and we will give the name for this, my role for Hazelcast create. So we have created the role for this one. Okay, let's start with the cluster. Let's create a new cluster for Forget, and I'll give my name my Hazel cluster and create. Let's view the cluster. Now let's create a task definition for this. Create a new task definition. Forget. Next, my Hazelcast task definition. Here we have to specify the role, and as you remember, we have created my role for Hazelcast. This is very important, and we have to provide the task execution role. Let it be that one, and I'll give the minimum space for the CPU utilization. Let's add the container. It's Hazelcast container. Image, I have my own image in the Docker Hub repository. I'll use the same thing. I'll give the in the description I'll provide the links for these GitHub and Docker Hub repositories. I'll provide latest. And soft limit 128. Port I'll be mapping to 80. Rest of the things is fine. Okay, let's add this one and create. Okay, now since task definition has been created, so we can add the service for this. So we'll go for a cluster, our cluster. We'll go for create service. I'll give forget and my Hazelcast task definition. My Hazelcast service. I'll give service two task. Two instances will be created along with this one. Next. So I'll go for the VPC which we have created, and for the subnets and security groups I have already created. I'll show you what is the inbound. Inbound I have given 8080. This is for my container and this is for Hazelcast cluster. It is 57701. So we can define as how it will create by default. Okay, I have taken the as my security group. Let's make it save. Next step. Next. Create. Okay. See here, two instances are running. I'll pause my video so that once it is running, I'll show the logs. Okay, I think now two tasks are running. We can choose either among them. I'll see the logs, how it has been created. Sorry for that. Okay, I think I'm feeling it is pretty healthy. Let's see whether the cluster has been created or not. Okay, so instance has been created. We can able to see two clusters available in that. Sorry about it. I opened my Office communicator, keep pinging me. Okay, I can cluster here. Later here we have created another one. So we can see the clusters are created healthy. So 2 cluster members have been added. Instance we have created. Okay, since services are running fine, what I'll do is I'll go back to the browser, pick the IP address. One of the IP address means 2 tasks are running for me, and I'll open the Chrome browser. /et/wiki. So if I give the first name, it will come along with the first name and last name from the database. I'll open the debugger mode of this one. Let me try the values. Okay, so it came pretty fast, 575 milliseconds. Let me try the second time. Second time is 204 milliseconds. So if you see the difference, previously it was 500 milliseconds, now it is 200 milliseconds. So our caching is working fine. We can pick any of the IP address. Let me go back again to the cluster. So previously we have taken 168 last number. Okay, this is 168. I'll take another one, which is 104. Now I'll go back to browser again, change it, hit wiki. See, you can see time will come in, okay, 1 minute 46 seconds. I think first instance. Second times it comes in 229 milliseconds. So the data has been cached. I'll give me another value. See, it is coming 500 milliseconds. Again, I'll try again. It's coming under 261 milliseconds. So the performance and latency will be reduced. Performance will be higher for this one if you add more caching for the service layers. Hope you like this video. If you like, press the like button and subscribe my channel for the further updates. Thank you very much. Have a good day.